So in this video, we're going to be going over Snell's law and its calculations. So we can cancel out these questions, which we'll be going over later the next week or so. Okay, Snell's law basically states, and use I equals NR sine theta R. So Ni sine theta I equals Nr sine theta R. Now, we talked a little bit about this in the last video. Sine is a function of that is related to the use of right angled triangles, and sine as a function always takes an angle value. So it's always a function, it's always sine of an angle. So that's kind of important. So sine can never be on its own. It always has to be sine of an angle. So when you put it in your calculator, it would in the button. Well, you press the button which has sine on it, and then you put that in your calculator. And we already talked about Ni and Nr being the index of refraction of the incident medium and the refracted medium specifically. So we're going to go over some definitions briefly before we get to calculations, which is the more important part. So we have, as usual, our incident ray. Our normal is defined as before. Incident ray is the ray of light that strikes the boundary between the media, or the interface between the media. It's the ray that's coming in and hitting that. So it's pretty much the same definition as the incident ray we've defined before. So I'm not going to write all that out. I'm just going to say the ray of light that strikes the interface between two medium. And then we have our angle of incidence, or theta I. Again, theta is just a Greek letter, which is like an O with like a little line halfway in the middle. And that's just a normal unknown for an angle. So just like we use x to represent unknown variables that represent numbers, theta is a commonly used unknown for an angle. So let's imagine we're going from air to water. So we're going from a rarer to a denser medium. And when you're going from R to D, you have to go towards the normal. So this is going to bend. That's a bad bending, but you get the idea, hopefully. And then just like we have the incident ray, we have our emergent ray, or refracted ray, as it's also called. And this is the ray of light that emerges from the interface. So that comes out from the boundary between the two medium. And just like we have our angle of incidence, we have our angle of emergence, or angle of refraction, which is why you get the R subscript. That's theta R, and that's the angle between the emergent ray and the normal. Again, all angles are defined with respect, or measured with respect to the normal, so that's important to be able to draw these things. Okay, now that we know what the values are in Snell's law, we can go about calculating this, and this will be one of the main calculations, so we'll spend a bit of time on that. We cannot do some of the questions yet, but we will be doing most of them, and so without further ado, we shall begin. What is the angle of incidence in water if the angle of refraction in air is 90 degrees? So again, for the first couple, we'll start writing our givens. So we have our incident medium is water, because it says angle of incidence in water. So our theta I is what we have to find, because it's asking what it is. Our Ni we will look up from a table, and we know that the refractive index of water is 1.33. You can add this extra 3. It's not really necessary. It's not really important how many decimal places you keep. I will mark both as correct. And of course, our angle of refraction in air. So our refraction, the second medium is air basically. Our theta R is 90 degrees, and our Nr is 1, which will approximate to be the same as vacuum. It's actually 1.003 or something, but we're going to round that to 1. Again, an approximation. Now we're going to use Snell's law, Ni sine theta I equals Nr sine theta R. 1.33 times sine theta I, which is, we'll just leave as sine theta I, equals nr sine theta r is sine 90. And this is a multiplication, so 1 dot sine 90. A dot is a commonly used symbol to indicate multiplication because x's or crosses, this gets too confusing because you're like, I don't know if this is an x or a multiplication, blah blah blah. So 1.33 sine theta I equals, again, it's going to be a bit difficult to show you how exactly I'm pressing this on the calculator, but I'm pressing the button that's sine, I'm typing in 90, and then I'm pressing equal to. If I want to include all of this in one calculation, I can just do 1 multiplied by 1 times sine 90, and I will still get, the calculator will obviously do that multiplication as well and give me 1 as the answer because sine 90 happens to be equal to 1. Now, here's the important part. I have to isolate for theta I. So I'm going to do this in the same way I isolate for any other variable. I'm going to divide first both sides by 1.33 to get rid of the 1.33. If you want to think about it, I heard most of the class people like to think about it another way, like moving the thing over. So I'm going to do the division, but you can also consider this is 1.33 is being multiplied into sine. So when I move it over, it becomes division. So I have to do 1 divided by 1.33, which makes sine theta I equals 0.752 approximately. Now we have another important step, how to get rid of the sine. What do I do to both sides, or how do I move the sine over to the other side? And the answer to that is I have to use another function, which is called the sine inverse. So it's written with a sine and the -1 on top, and it's usually written in letters above the sine button. You'll see the sine -1 symbol. So I'm going to see if I have space here. So sine inverse of sine theta I equals sine inverse of 0.752. So the sine inverse and the sine kind of cancel each other out. So what I'm left with theta I, which is good because that's what I want to isolate for. And this leaves me with this calculation. Additionally, or alternatively, if you want to move it over to the other side, and you're starting with sine theta I equals 0.752, you'll note that when you move the sine over, it always goes over to the front of the other side. So you can't write 0.752 sine, or 0.752 divided by sine, or 0.752 sine inverse. All these things are wrong because the sine inverse function always goes right to the front of the other side, basically. So this becomes theta I equals sine inverse first, and then you put whatever was sitting on your other side. In this case was 0.752. So, and here what you do is usually you press the shift button on your calculator or the second function button on your calculator, and then you press the sine button, and you'll see a pop-up saying sine inverse. And this is how the shift or the second function is usually used to get access to the little the thing that's written on top of your sine of your calculator buttons. So we'll press these buttons, sine inverse, and then you type in 0.752, close the bracket if necessary, and you have theta I equals 48.76 degrees, and this is your angle of incidence. So it's a bit challenging, I'll admit, to be able to get to that, but it's important to be able to know how to. So I think we'll go over a couple more, but we'll pick up the pace because you don't want to watch an incredibly long video. I'm sorry if that was super slow. Light from water was observed to enter a medium. So I don't know what the medium is. So I don't know what this medium is. Theta I incident angle is 51 degrees. Oh, I do know what the medium is. From water. So this is water, so I know Ni is 1.33. I don't know what the refracted medium is, but I do know refracted angle is 44 degrees, and I have to find Nr. The question is asking me what the medium is, and if I find Nr because it's a characteristic of the medium, it's a property of that medium, I can look back at my tables and find out what the medium is. So again, I'm going to use Snell's law. I'm going to do Ni sine theta I equals Nr sine theta R. So I've done the substitution already. This I can put in my calculator just as it looks. So I'm going to put 1.33, press the sign button, 51, and then equal to gives me an answer of 1.034 equals Nr. And sine 44, again, I'm just going to put in my calculator to give me an answer, times 0.695. And then to solve for Nr, I'm going to divide by 0.695. So 1.034 divided by 0.695. Nr gives me 1.49, which I'm pretty sure is a kind of glass. So that's the, you have to check the tables, I'm too lazy. Or actually, I think it's somewhere at the back. Acrylic. Acrylic is the medium. And how fast does light travel through the medium is you have to do N equals, you want to find velocity, so that is c divided by n, which is 3 times 10 to the power of 8 divided by 1.49, which is equal to 2.02 times 10 to the power of 8 meters per second. So these are only the basic two types. I can either ask you to calculate an angle, or I can ask you to calculate a refractive index value. So I will let you try the other calculations on your own, and of course I will post an answer key so that you can check your answers on the hub. So yeah, hopefully you now understand how to do these calculations if you were struggling before, or didn't know how to do them before, or just needed a refresher. I will see you, everybody, in class.